Go away. Yesterday, we talked about congruence criteria, and we were working on that website trying to figure out which of those shortcuts actually work. So remember, when we want to prove two shapes are congruent, it takes a lot of pieces of things, or a lot of pieces of information. What do I have to go on here? That one. Perfect. All right. Sorry, let me fix that very quick. All right. Let me make sure this one's still recording. All right, cool. Sorry about that. Okay, so in order to show two shapes are congruent, it takes a lot of information. We have to show every single side matches every other single side, and every single angle matches every other single angle. That's a lot of information to check for. And so yesterday, we were trying to see, is it possible to use some shortcuts? With triangles, our most basic of our shape, is it possible, rather than having to check every three sides and every three sides and every three angles and every three angles, is it possible if I could just check the three sides? Or maybe two of the sides and one angle? Or maybe two angles and a side? Or maybe two sides and an angle? Is it possible if we are given just some pieces of information, is that enough to show that they're always going to be congruent? And so that's what we looked at yesterday. And so using those notes from yesterday, which of these congruence criteria, which ones worked and which ones didn't work? So that one worked. Good. What else worked?
Side, angle, side.
Side, angle, side. Okay. Angle, angle, side. And angle, side. So these were the four ones that worked, correct? And the two that did not work were side, side, angle, and angle, angle, angle. We'll talk specifically on why those two didn't work today, and we'll also talk about why these ones always make it work out and why these ones have to work today as well. That's basically going to be our thing. Why did these ones work and why did those other ones not work? So, you should have all received a piece of paper that has the different criteria proofs at the top. It starts with side, side, side on your first page, and then it goes side, angle, side, and we should have those four on the front page, right? All got that. All right, so what we're going to do today is we're going to walk through each of these. Why did this one work? And why does it always force congruent triangles? And why did this one not work? And why did it not force congruent triangles? And whatnot. So our first one is side, side, side. And so with side, 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 that means you are making the same triangle with the same three sides. So basically what happens is you take a triangle and you form those side lengths. And you then are trying to make another triangle using those same side lengths. That's more accurate. So we want to figure out, why does this always give you the same triangle every time? Why can you not make a different triangle using those same side lengths? It's all of them equal.
But it doesn't, so like, each of the triangles, they don't have the same side length. But that's what makes the other one congruent, because it also doesn't have all the same side lengths.
Well, that's the over time.
So like these little dashes mean like this is a different side length, this is a different one, this is a different one. And these are in the same spot.
So what those dashes represent is that this angle right here is the same, or this side length, I'm sorry, is the same length as this side length. This side length is the same one as this one. And this one is the same one as this one. They don't necessarily mean one is not the same as two. They might be, but they're not necessarily. It doesn't necessarily tell us.
Okay.
But 3 is the same as a 3, a 2 is the same as a 2, a 1 is the same as a 1. So basically, we build a triangle with 3 different side lengths, and we're trying to build a different triangle with the same 3 side lengths. But yesterday, we figured out this doesn't work. It's impossible to build a different triangle. But we want to think through what might be some of the reasons on why. Why might this not always, or why does this always give you a congruent triangle, and why is it impossible to try something different?
Because every triangle is going to have a different side length.
Okay. So if I use 2 of these side lengths, say the 3 and the 2, and I make a triangle, or I make an angle with them.
Left over the 1.
There's only one distance that's going to fit in that angle, right? I have this 1. I have to get that 1 to fit in that angle. But if I don't make that angle wide enough, I can't fit that angle, or I can't fit that side in there. So there's only one specific angle measure that I can put these two angles at to fit that other side length in there. And so that restricts me to only one option for this triangle. I can only use one specific triangle. I can only use one specific ordering of these side lengths to fit that last side in there. And so side, side, side restricts you to only making one triangle because of the specific length of your sides. So basically for the what do you notice, we can say 3 sides forces, or two sides, we'll say, forces the length of the third side. And so because we already have that third side picked out, we already have a length for that third side, it is impossible for us to change what those other two, what that angle is. And therefore, all of those angles will have to be the same in order to get, or because of those 3 sides. We can't move it whatsoever. It's rigid, it's stuck. We can't change those angles. There's no other triangle we can form. And so we also want to practice being able to write a congruent statement. So once again, a congruent statement is that little way we write to show what one triangle is congruent to the other triangle. So for example, we have triangle ABC. So the way we typically write it is we start off by naming one of the triangles. So I'm going to name ABC. Okay, like that. And I'm going to say this is congruent. But I need to figure out what is this triangle congruent to. So if I look, side AB, why is that right? That's been weird recently. All right, so side AB, that has 3 hashes. So HG also has 3 hashes. If I look, A is in between the 3 and the 2. G is in between the 3 and the 2. So angle A relates to angle G. I know AB relates to GH. That's my next letter. And then my last letter, C, relates to J. And so ABC is congruent to GHJ. That would be my congruent statement. Are we okay with the congruent statements and writing that again? Like what we did on Monday, I think. All right, so that is side, side, side. As we go through these, it's annoying to have to write side, 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 or side, or side, angle. And so we just shorten it down to 3 letters. So we're going to shorten it down to S, S. And that's sort of your abbreviation you can use for some of these. So for example, side, angle, side is just SAS. Side, angle, side. And so rather than having to write all those letters, you can use those abbreviations. So that's what I'm going to side, side, or angle sometimes. All right. So just like we do with side, 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 we want to figure out, is it possible to determine why does this one always produce congruent triangles as well? So with this one, you're given an angle and 2 side lengths. We have that the same on both triangles, and we're trying to make a different triangle. And we found it impossible. So we had a side length, we had 2 side lengths, and we have an angle. So that was our first triangle. We use that same situation. We were saying, is it possible to find a different triangle from this situation? What was that? Say it one more time. Oh, I didn't draw my angle.
I didn't know that was.
Thank you. So yeah, I have the same angle, so I can't change that angle. I can't change those side lengths. Is it possible to get a different triangle here?
Why isn't there a dash at the bottom? Why isn't there like 3?
You could just have 3 like that.
Okay, I'll put that there. Yeah, I just didn't know.
Is it possible to get a different side length?
I don't know.
Why not?
Well, there isn't a line.
Yeah, I mean, only like one, you can really like close the triangle, you know what I mean? You can, like,
So that-
perfectly.
Good. That gap in there, there's only one length for that. there's only one length that's going to fit these two, or in between these two lines. There's only one line that is going to be perfect to connect those two. If I drew it too large, I'm going to be extending out, and that's not going to make a triangle. If I drew it too short, it's not going to be able to touch between the two. There is only one length, and that length is the same one we had over here. No, I'm on my other side. And so that 3 dash length is the only one I'll be able to use. Are we okay with that?
Yep.
And so for the what do you notice part for this one, we could say something along the lines of the sides around the angle forces the length of the third side. And so side, angle, side. If you have two side lengths and an angle in between them, no matter what, if you create two shapes with that, they will always be congruent triangles. You will always have to have that same side length to finish them out. You can't get a different one. And so if we were to create that congruent statement again, just like we did on the first one, we need to name the triangle, so DEF, and we have to figure out what that's congruent to. So if I look, D falls in between my 1 dash side and my unhighlighted side. That's the same as L, so D is the same as L. DE has 1 dash, that pairs with, I don't know what that is. This thing's doing all sorts of stuff today. So DE pairs with LK, so we know K is the next letter, and that brings us down to EF or KF. So our congruent statement would be DEF is congruent to LK now. Are we okay with that? Okay. So we did 2 of them so far. So we've talked about side, 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 and side, angle, side, and why they always work. We have our 2 other ones, angle, angle, side, and side, angle, angle. So once again, just like what we did with the other one, we want to figure out why do these 3 components always give us congruent triangles, and why can't we have anything else? So with side, angle, angle, you're given an angle, or we have 2 angles, and we have 1 side. We have that one of those angles has to touch that side length. It's going to be on 1 side, and you create a triangle with that. We want to figure out, having that same situation, why does this always give us the same triangle? I know my side lengths aren't necessarily the same side. Pretend they're all. So both angles are the same. In order for this angle to make a triangle, it's going to have to fall along that line. Pretend that's straight. It's going to have to fall along that line in order to make the triangle. And it's going to basically, if you're imagining it like shooting out a laser, it's shooting out a laser somewhere over in this distance. If we were to move this angle farther along that line back up, is this laser, is this going to get farther out, or is it going to get closer in? It's going to get farther out. As it gets farther and farther away, that angle is going to shoot farther and farther out. If we were to pull it in closer, that laser is going to get closer and closer in towards our original angle as we get closer and closer down. But we want that laser, in order to make a triangle, we have to get that laser touching that endpoint. How many locations do you think there are along that line for that angle to be to get its laser touching that endpoint if we can't change the width of that angle? There's only going to be 1 spot. It's going to have to be fixed in 1 location in order to get its angle laser, as we're using it, to touch that angle. There's only 1 specific location, and you can guess it, it's going to be the exact same one that we had on our first triangle. And so because those 2 angles are restricted to fall on that line, and because it's restricted to meet a certain distance, to meet a certain length, there's only one possible location for that second angle to be on that line to make a triangle. So that's a lot of stuff to be able to put in the what do you notice. If we were trying to paraphrase it, we can say the second angle only has one location along the first angle. To make a triangle. And so those triangles have to be the same because there is only one possible option. There's no other way we can get a different triangle. So those triangles have to be congruent. Are we okay with this? Thumbs up, thumbs down? So if we were to make a congruent statement off of this, if I were to start with ABC, what would you say is the second half of that congruent statement? What triangle is congruent to triangle ABC?
Was it ST? Oh wait, no.
SRT, good. So A pairs with S, B pairs with R, and C pairs with T based off of our angles and our side lengths. And so that will always work out. Are we okay with this? Congruent statement? Awesome. We have one more final one to talk about. I think this one's a little bit easier to figure out if you look at the situations. And so, I'm going to come back over to this side. So we have angle, sorry, this is angle, angle, side. This is angle, side. That's all. Angle, side, angle. So with angle, side, angle, you have a line segment, and you have two angles on each side of that line segment. And they come together to form a triangle. So if we have that exact same situation, why would this always give us the same triangle? Both those angles, we can't change how far away they are. We can't change how wide they are. They're both, if they were both shooting lasers, we go back to the laser idea. They're both shooting lasers. It's going to have to intersect at one point. And if we can't move these at all, we can't change these at all, they will always intersect at one specific spot, just like that, how they did up here. And so if we can't change that situation, they will always shoot that exact same intersection, and so we get always the same triangle.
I get the laser thing. You kind of lost me in that first example, but now I do.
I'm sorry.
That's laser. I was like, lasers, but like now I do.
And yeah, pretend like a little
Yeah.
laser gun or something. I don't know. Shoot a little laser, or if it was like a laser pointer, the more school appropriate example. Alright, so for the what do we know, or what do we notice, we could say something along the lines of, and you can of course paraphrase from whatever, say, the two angles are always going to hit the same intersection. No matter what, we can't move those two angles, can't move their location, can't move their width or degree measure, and so they will always, their laser will always cross that same spot if we were to track laser pointer to or something. That is our congruence. Alright, so what would your congruence statement be for this one, if you were to create the whole thing yourself?
JET is congruent to dog.
Jet is congruent to dog?
Yes.
Let's see, do we agree with this? Is jet congruent to dog?
Yeah.
So J is our single arc, D is our single arc, E is our one without an arc, and then T's are both our twos. And so jet is congruent to dog. Awesome. Yeah. So we talked about a lot of things. 4 different things, and we sort of were able to talk about why those ones worked, but we also need to talk about why did these ones not work? Why did these 2 not work? And if you think about it, with side angle, or side-side angle, you have 2 sides, and then we have our little angle. And once again, think about that angle having a little laser at the end of it, it's shooting away. There's a couple things we can do with that other side length. One, that side length can probably touch up here, but if we think this side length is it's like on a hinge, it can pivot, it can switch. It can also, using that same radius, touch down here. That gives us 2 different triangles. We have our larger triangle and our smaller triangle. So because that one side length is on a hinge, it's not restricted, it has a couple options of where it can intersect that laser. And so it gives us 2 options, which is not what we want. Those are 2 different triangles. So that's why side-side angle does not work. If you want a quick, helpful reminder to not to use side-side angle, if we think about the letters it spells, I'm glad Mrs. Silver isn't here for this part. If we think about the letters it spells, it's SSA. If we flip that around, that's not something you can say in my classroom. And so this is the reason we cannot use this in the classroom, because it gives us a bad word.
That's one way to find it.
So that's the way I always tell my students, if you want to try to remember or in order to help you remember not to use SSA, if that's your situation, and you come in with SSA, just flip it around and realize, oh, I can't use that in this classroom, so don't use that criteria.
I thought about that when you were like, do initials. I was like, we tried to say that one other time.
So this is the one we cannot use, unfortunately. There actually is one situation where this does come in, but we give it a different name because it's special. But we'll talk about that one tomorrow. The main ones we want to focus on are these 2. And angle. The reason this one doesn't work is angle. You can create 2 triangles that look exactly the same, but just have different sizes. They have those same angle measures, but we can stretch all those angle measures out, and they'll still touch each other. Or we can shrink them really close in, and they'll still touch each other. But obviously, this isn't congruent. Because once again, congruent means congruent angles and congruent sides, and those sides are not the same. We can think of this like a dilation. So out of our 4 transformations we talked about at the beginning of the year, rotation, reflection, and translation, those all kept congruence. They all kept the shape the same. The only one that actually changed the shape was dilation. And that's why angle does not work. It's because it's a dilation and not one of our other transformations.
That's it.
Yes.
Does not work.
Will not work in my classroom or any classroom.
Ow.
Yes. All right. So we talked about quite a couple of different things. We talked about all 4 of these. So now we just want to see a couple of situations on when we would actually use this. It's a lot to be able to remember, but that's what next week's going to be for. It's going to be able to cracking these down and being able to keep them in our memory and knowing which situation comes up when and how can I use them, and sort of making a more formal argument with them. But today we just want to practice seeing some examples where we actually do use them. So this should be on the back of your paper. Our goal is just to figure out which criteria works in each of these situations. Which is it side, side, is it side, angle, side, or side, angle, side. No, angle, side, angle, that's my 4th one missing. So, looking at this first one, we're told we have some matching sides on both parts of our triangle. So once again, we need 3 pieces. 3 pieces on this side, 3 pieces on my top triangle, that matches 3 things on the bottom part of my triangle. So you need 3 pairs or 3 matches on each triangle in order to prove that they're congruent. Right now, I have 2 pairs of matching sides. I need 1 more piece of information in order to show that these 2 triangles are congruent. So what do you notice?
Side, angle, side.
Side, angle, side? So where do you get that 3rd angle from, or that 1st angle from?
Just throw it out there. Because I mean, it couldn't be another side. Yeah. Is it good because in the bottom and the top?
But do we know anything about those sides?
No.
No, so we can't. So we don't have enough information to say it's side, side, side.
But we don't have an angle.
I mean, A kind of makes it.
But I don't know.
What do we call these types of angles?
Vertical.
Vertical angles.
Wow. Close.
We know vertical angles are congruent, and so we do have side, angle, side.
Travis.
The reason this is side angle side and not SSA is because that angle falls in between your two sides. It's included. So both of those side lengths are on the sides of your angles. That's why it's SS or side angle side and not SSA. So where the order happens on the triangle is important. It does change. And it is because that gives us one thing compared to this. So we don't use this one. Get that out of here. But because those are vertical angles, we do have side angle side. Let's look at this next one. We're told a couple side lengths are the same. So I'm told these two side lengths are the same. I'm told these two side lengths are the same. So I have side and side. I need one more piece of information, one more pair.
A. Side. Darn it.
What side do they have?
E and I.
So they both share this middle side. And because they both share it, it's obviously going to be the same. And so we have three congruent sides. Therefore, side 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 says these two triangles are therefore congruent to each other. We could also write our congruent statements if you want. So our first one could be ABC. We would say ABC is congruent to ADE. Technically, because each of these sides are the same length, it could also be congruent to AED. It really doesn't change the situation actually. So that one's pretty cool. Because you have two isosceles triangles. For the congruent statement for our second one, you might say something like GIE. So GI is congruent to VI. IE is congruent to IE. And then EG is congruent to EB, so that works. So guy is congruent to vi. I like to try to throw in words if I can. It's like jet dog in there, but not all of them have words. All right, so you have two more. I want you to try to go through these two on your own, see if you can think of what of those criteria works and what situations am I having for both of these. So see if you can try to finish these last two on your own. I'll be walking around. All right, so what did we find for that first one that we tried on our own?
Sets. Oh wait, no. That was only the other.
So angle, side, angle? How did you come up with that? What were your pairs you had?
Angle pairs, and over there like the right angle.
You had your right angles, good.
And then you have like the side.
We have this side paired with this side, good.
And then you have your vertical angle.
And then we have vertical angles. Once again, because that side length falls in between your two angles, we need to draw our side length in between our two angles out here as well. So good. And then you could say something like SMI is congruent to E. SMI is congruent for SME is congruent to EI. Whatever word you want to call that. All right, what about our second one? What congruent criteria did we use for this one to show that they're equal? Angle, angle, side. So what were some of the pairs you used? What were the pair of angles you had? So we were told those two outside angles to start off with are. We have two right angles. Anytime you have a right angle next to an adjacent angle and they make a linear pair, we get the other right angle. Good. And what side do they have? We have our XU shared side in the middle. We call that our reflexive property that we'll talk about next week. And so we have side or angle, angle, side. And once again, just like how this one, the side length was in between the two, this one, our side length is outside the two angles, and so we draw our side length subject to angle here. And then you can come up with your congruent statements. What? Tux is congruent to lux. Good. And then you're done. So once again, we're going to talk about this more in a formal argument tomorrow. We'll add in one final congruent criteria that's a little bit different, that doesn't come up as often, but does show up sometimes. And then next week we'll talk about the proofs and actually practice through these and why.